Alright, the draw science video, and mostly going to be about light and such, I suppose. Two-slit experiment, I think, is what I'm going to talk about. And just how irritating it is that, scientists aren't picking this stuff apart a little better in terms of describing what's happening. Lots of mistakes being made, I think. Anyway, some two comments. Matthew guy says it's going to take me a while to get through this, but I will eventually get around to adequately responding. Okay, thank you. Alright, then this Roberto 2. In his Nobel Prize lecture on the transistor, Bardeen explicitly acknowledges the role that theory played in guiding the experiments. Right, but the theory is just this simple conceptual notion, okay, that this is a phenomenon that takes place with photons. Again, this is all stuff they knew about, okay? They knew about photoresistors before they invented transistors, okay? I mean, they knew about crystals, and they created an electrical current when they were mechanically bent, and then they noticed that other substances, when photons hit it created an electrical potential. So this is all stuff they knew. So I'm just saying they didn't need to do this math to do any of the experiments that led to the invention. I don't think the math played any role whatsoever. Quantum mechanics, I don't think, played a single solitary role in actually developing the device or understanding its potential to exist. I mean, they were already in a division called solid-state electronics. They already understood the concept of migrating from, light bulbs, to a more efficient way of regulating voltages. The general aim of the program was to obtain a complete understanding as possible of semiconductor phenomenon. Well, that wasn't true. Not in empirical terms, but on the basis of atomic theory. Well, I don't think that. I just don't. You're quoting this. You think that Bell Labs had that as their that was their program's purpose? You really think that Bell Labs had a program that just wanted to completely understand, and that's why they call it solid-state electronics? No, I don't think so. Anyway, a second theoretical foundation was available from work done during the 30s. Well, whatever. 1. Wilson's quantum mechanical theory based on energy band model. Well, I don't know what that is exactly, but I bet it's, again, something we don't need quantum mechanics to understand this quantum mechanical theory. Frankel's theories on certain photoconductive phenomenon. Yes, so this isn't quantum mechanics either. Okay, this is just an idea that, look, there's a phenomenon. Yes, phenomenon. Okay, every phenomenon, it doesn't, everything can be cut. As I'm pointing out in this fucking video, you retard, everything is light. So you want to call everything that happens photomechanical? You want to call photosynthesis quantum mechanical? You want to call me quantum mechanical? Everything's quantum mechanical, right? Bullshit. I mean, this is just bullshit. Anyway, I don't know if there's so much of this. Let's go. Shockley, and for his part, literally wrote the book on quantum mechanics of semiconductors. The quantum mechanics of semiconductors, and how would the quantum mechanics of semiconductors be different than the quantum mechanics of any other kind of conductor? Oh, that's right, it wouldn't be any different. Electrons and holes in semiconductors. I'm quoting that. Online version available, blah, blah, blah. Yeah, well, I read the history of semiconductors when I was about 13. Because I worked with them. So, yeah. But whatever. Keep dreaming that it had something to do with quantum mechanics. Go ahead. Quantum mechanics, but I'm just saying, go ahead. Show me a note. Show me something real in there. Show me some piece of an experiment, something that happened in the laboratory that had quantum mechanics as a critical part. They couldn't have done it without it. And you're not going to find it. Do you think it is a mere coincidence? No, I don't think it's a mere coincidence, idiot. Obviously, people who would be involved in semiconductors and doing something innovative with semiconductors would be sort of cutting edge on understanding the physics of semiconductors. That would seem logical. I don't think I'd have something called solid state electronics as a division at my company and then let a plumber and a shoe shine boy be the people who run the division. I don't think that's what I would do, fuckhead. Let's see. Translator just happened to have an intimate knowledge of quantum mechanics of semiconductors. Well, again, quantum mechanics of semiconductors is another parsing of the conversation. I think it's just absolutely silly. The only thing that's like saying the difference between waves in molasses and waves in whatever shampoo. Why would I make silly distinctions like that? Yes, the waves will behave differently because the densities are different, but the quantum mechanics is the same. All you've changed is the chemistry of the quantum mechanics, and obviously there's chemical changes for everything. So that's called chemistry. It's not called distinctions in quantum mechanical theory. Of course, it was because of knowledge of the invention was possible. So there he says it right there. The invention was possible. I just say that's an outrageous statement. I say the invention would have been invented, it would have been discovered, just like E equals mc squared, just like everything else in science. It all would have been discovered. Quantum mechanics adds absolutely nothing in terms of providing opportunity for discovery. It does nothing. You have to do the experiments. Quantum mechanics doesn't even resolve a problem at all. All it does is does probability math, and it's really useless probability math. Incredibly useless probability math. Yeah, I mean, really, this is just so irritating. So you can't see the smallest thing. This is what quantum mechanics is. You can't see the smallest thing in the universe, right? Because you can't have glass. You can't bounce light off of light. So it's kind of an obvious problem. You can't fuck with the light without fucking up the light. And so they deal with this problem by saying, look, the light's somewhere around here. If we try to see it, we'll fuck it up. And so instead of trying to see it, they just say it's somewhere around in this blob here. And then they just move the blob through the math. And then give you a solution over here that says, see, this is where the probability leads to. It leads to a blob over here. This is where it goes. And with quantum, with photons, as soon as you have that photon interact with an electron somewhere in that path, you will end up creating phenomenon of probabilities that will create distinctions, like these fingers. So instead of the blob ending up over here, like you start off with a blob in a circle, and it'll end up at the end in fingers. That's quantum mechanics. It's just the recognition of this part of the equation. The recognition that photons, when they interact with something, will change where they're going to go. And it's going to happen in this proportional way. So that's all it is. So all this hype is about absolutely nothing really. It's about phenomenon of the mechanics of photons, and electrons are made out of photons, in my opinion, and obviously by experimental results it seems quite obvious that electrons will behave just like photons often in terms of what happens when they interact with something. Alright, so to the two-slit bullshit. Yeah. Alright, so part of the two-slit experiment, so you just have this experiment, you have a gun that shoots. Let's put the gun over here. So you have a gun that shoots, then you have a hole in a thing, so the bullets go and we go through the hole. So that's the first interferer. Then you have two slits over here. They'll be like next to each other, really close. And then you have a target. Everything falls on the target. Okay, everything hits the target eventually. And that's the two-slit experiment. Okay, so, well, I could draw it. I mean, you've probably seen it, but I guess I could draw it. Well, I'm going to draw it because I'm going to illustrate something. So let's just deal with the first mechanism of interference. So instead of just pointing the gun at the two slits, they first force the gun to shoot through a hole. Why do they do that? Why do they need to do that? Why is that a necessary feature of the two-slit experiment? Why would you focus, right? And so you know what's going to happen, right? If I have a hole and I move that hole away, you can see less and less and less and less of my face, and eventually you'll just see one little tiny part of my face, right? So a hole, depending on where you put it as a focus, will constrict what light can go directly, a straight line, and it will change what light can be bent. So that's creating the interference, right? So let's draw that up. Alright, so this is a critical part of the two-slit experiment. Is, okay, you have a gun that shoots kind of wildly. Alright, scatter gun. That's an integral part of the experiment, is not shooting photons straight. You must shoot them erratically. Now that should be a giveaway, right? It really should be. So, and then you have a little hole here. Okay, there. So now you're going to shoot this like this, and then but you're only going to allow these photons here to go to the two slits. Okay, so that's the catch. So there's your first bit of interference is this hole. And what's its purpose? So what I'm going to argue is obviously because of the distance it is from the gun, the further away from the gun it is, the less of this you could get to. So if this hole was really close to the gun, then you could still have a direct line where a photon could shoot from the gun, go through the hole, and get through the slit without ever being interfered with. There'd be a direct line. But the further away, the further this distance is, the further this distance is, there's a point where the only way a straight photon could go anywhere, it would have to hit the barrier between the slits. It cannot possibly, a straight photon cannot hit it. So what's happening, quite obviously, I think, is this. So here's the hole, and here's the gun. The photons, the only photons that are ever going to go through one of these slits are photons that have to be bent by the edge of the opening. So it's only photons that are close enough to that edge that'll ever get through the slit. And so they have to interfere with this material. Okay, that's it. The material of this slit, they have to interfere with it to make it to a slit. So that's the first interference. And what I'm arguing is just like a prism splits light, into its colors. The yellow ones will go this way, the red ones will go that way, the blue ones will go that way, kind of idea. The same thing happens in this interference. Okay, depending on the condition of the photon, it will go different amounts of bend. So let's say that the photon has 16 character elements that add up to kind of a weight. So it can be from a 16 to a 1 in terms of this weight of electrical potential. We could even call it electrical potential. It doesn't matter. We just invent any variable that we attach to this photon that's similar to yellow, red, blueness. So it's similar to a primary color aspect, but it's still a gradation. Or you can even say it's a gradation within those ranges. All yellow light isn't exactly whatever the frequency of yellow light is. But anyway, the wavelength of. And so obviously any variations in wavelength, even a tiny, tiny little bit, that would change how much deflection you'll get in its interaction with this material. Now obviously the other thing that would change it is how far away it is from the material. But, so that we have two variables there that will change this pattern. Now what we also notice in reality is that there is a linearity to these things, right? Rainbows have bands. There's bands in a lot of features of filtering. So as soon as you start playing with light and filtering it at all, any kind of filter, you'll often create bands. We see these optically, even in this camera. It might even have one of these little circles in here. It might even have and there'll be bands in those things. Those artifacts will have banding taking place. So this is a common phenomenon of photons, that they are deflected different amounts, and that those amounts are very regular. So I think quite obviously you're creating a mechanism of deflection. So the photons leave the gun, they are deflected variably, then they go to the slits where they are, again, the exact same phenomenon takes place, where now you're angularly hitting the slits. So this is the second argument of the two slit experiment. I probably should just stick with one argument, but let's do both of them. Alright, so now I've explained one source of interference. Now the second source of interference would be, now that we have created this hole, so this hole is where the gun really shoots through, so so we know that the only photons are coming out of this hole. We know this hole's focus length to here would be that you could only straight line to here, you could never straight line to this slit. So you know that every one of the photons coming off of here has been deflected. So it's coming at an angle into the slit. Now as soon as you create an angular, as soon as you approach a slit from an angle, let's make a two-dimensional picture. So here's the angle you're coming at. So the more angle, like if this was straight on, you would see none of the sides, right? You wouldn't be, there'd be no profile. There would just be an opening, ideally, if you're going straight on. Now the more angular you get, the more of this angle you're going to see, and the more likely you are to roll over this edge. So the more I turn your angle, the narrower the slit gets, and the more surface you're likely to interact with. So now you're more likely to create reflections off this surface, and certainly more likely to create deflections off these surfaces, refractions. So once again you're going to do the same thing that took place over here. You're going to once again create another filter that's likely to create refractions, okay, or bending of the pathway of the light. So the light's pathway is again going to be bent by the slit itself. So you have two mechanisms that are bending the light, and then we're supposed to be surprised that on the target you have a pattern that is lost its fringes, essentially. So what happens in the two slit experiment is you can kind of argue that this should look like a constant little blob of light, brighter in the center and weaker on the two sides, and what you're ending up with is these bands, and all that's really done is the fringes between them are gone. So the fringes are dead cold instead of hot or warm, and that's basically what's happening. But how they're not doing this experiment is the easiest way to verify that this is a phenomenon of some magical origin, or it means something like photons can tell what you're doing, is if they did this experiment by actually blocking the slit. And they don't really do it that way. They reset up the experiment. So they do the experiment first with one slit in the middle, and then they put two slits in the middle, okay, meaning they have the bar in the middle, the blockage, and then the two slits. Interesting. So they've cheated the experiment essentially, because they're not, these two slits are, as this focus indicates, off center. They're not on center, they're on the fringe. So when if I was to focus this beam of light, and you could see it as a focus as like, harder in the center and then weaker on the outside, the focus is around the whole two slits. Alright, so obviously you're getting the fringe photons going through the slits, and the straight photons are hitting the center impediment. So obviously if you move the slit material to recenter it to do one slit, you're changing what photons you're going to get into the slit. You're back now to the straight line photons. So as soon as you take one slit and move it to the center, you're basically allowing a photon to go directly straight right into the target. That's what you're creating the opportunity for. So you have to keep the slits, cover one of them mechanically to do this experiment properly, and never move this. Don't move any of these features. You can't move any of these features and then redo the experiment. So the only thing you can do, the only thing you can change in this experiment legitimately and claim if you get the same result or some great difference in result, you only change one variable. If you're changing two variables at once, you don't have a legitimate counter experiment for comparison, because either one of the variables or both the variables combined could have created the change in results. So for them to say, we can't tell, or we can't blah blah blah, well, of course we can. If we cover one slit, you'll get a pattern if you leave the slits in the position they were in, which is off center and likely to create refraction, and then had exactly the same intensity of light. And that's the other cheat they do here, is they don't necessarily do the two slit experiment honestly, in the sense that when they have two slits, two openings, they don't allow twice as much light, exactly 2x light. And so, you know, obviously when there's one slit open, you should wait for a certain amount of radiation to hit the target, and that should be, you know, A1. And then when you have the two slits open, you should wait till you have 2A amount of light hitting the, or radiation hitting the target. And they don't even test for that, which is outrageous. So anyway, the two slit experiment is a huge fraud, and till a real scientist does it with some sort of caution and care and isolates the variables in a clean manner. You know, you puts gloves on to do this. You know, this is like a doctor not wearing gloves, the way these scientists, these physicists are doing these experiments. These are the sloppiest. They're very high-tech experiments, and yet they're so damn sloppy. It's incredible that they can claim these results have any meaning whatsoever. So, very irritating. So anyway, just understand. I mean, all you really have to do is keep asking yourself the question, why is this target narrower in the experiment? Why do they need this? If they just create a wall here that can't be seen past, if they just make this a completely closed wall, put the whole gun inside a box, why would they need this? And the answer is, well, because we have to create crooked photons. That's what it's there for. How can we possibly have deflection and refraction results if we don't refract the light? We have to refract it. We have to filter it before it can come out filtered. So that's what it's for. It's for creating the phenomenon. You don't have the phenomenon without it. So anyway, you don't have your magical two-slit mind-reading photons going through both slits at once and all this crap if you don't have that game screwer in the model. So anyway, it's a focus, it's a lens. That's what that is for. Its deliberate functional purpose is to fisheye the light.